Hello, hello. We are back talking about Chapter 8, Lesson 5, Direct Variation. Today, our objective is to learn to recognize direct variation by graphing tables of data and checking for constant ratios. So here we go. A direct variation is a linear function. Linear means that it is a straight line that can be written in the form y equals kx. That is direct variation, y equals kx. Well, the y is pretty normal. The x is normal, but this k is different. What is k? Well, it says where k is a non-zero, it can't be zero, constant. Constant means it's a number, called the constant of variation. K is called the constant of variation. All right. So you are going to have to recognize different direct variation problems. So if something is of the form y equals kx. Okay, so let's talk about one of the forms that we learned before. Let's talk about slope-intercept form. Okay, this is direct variation. Direct variation. All right, got it. Now let's talk about slope-intercept form. So, slope-intercept form is, remember, y equals mx plus b. Y equals mx plus b. That was slope-intercept. Whoops, that's getting kind of close. Form. Y equals mx plus b, y equals mx plus b. Slope-intercept form. Now, what is the same, what is different between these two forms? Okay, let's think about it. Well, let's look. They both have y equals. They both have an equal sign. Awesome. They both have an x. You see that? So they both have, let's see here. I'm going to say that they both have y. So they both have that. They both have an equals. They both have an x. But if you notice, for the direct variation, there is no b. And here the slope is now a k. Do you see that? The number right next to the x? Well, okay, so there's kind of two different things. What this means is that everything that you learned about slope is actually the same thing as a constant variation. It's just a different way of writing it. So the slope is equal to the constant of variation. That is the slope of a direct variation. It is now called the constant of variation, and they give a lovely letter K, but that is the same thing as M. Okay, so that's the first thing that is a little different about direct variations. The second thing, if you notice, there is no B. And that is actually not quite there. There actually is a B, but there's nothing here. That means that because there's nothing, the B is equal to 0. That means the y-intercept is always equal to 0 for direct variation equation. The y-intercept is always 0. So if you have a particular equation like, let's say if you had something like this, y equals 3x plus 2. Well, in this equation, there's a plus 2, okay? And if we wanted to say, hey, is this equation right here a direct variation? Well, what we could say just by looking at it, because it has a y-intercept that is not 0, this is plus 2, that means it is not a direct variation. So this is not a direct variation at all. Not a direct variation. However, if you have something like this, y equals negative 2/3 x. Well, here the y-intercept is 0, and this actually is a direct variation. This is of the form y equals kx, where our slope, or our k, is equal to negative 2/3. Negative 2/3. And our y-intercept, if we were to graph this, is actually equal to 0. So let's go ahead and graph this, okay? So there's nothing here. That means my y-intercept is 0 right here. And I'm going to just graph the slope from this point. So down to 1, 2, and over 3. 1, 2, 3. Right there, down 2 over 3. Everything is exactly down 2, 1, 2, 3 over 3 this way. And then the same thing the other way, up 2 over 3, 1, 2, 3 this way, up 2 over 3, 1, 2, 3 this way, up 2 over 3, 1, 2, 3 this way. And so that would be our direct variation equation here. Right there. That's our lovely direct variation. Okay? We could do another equation here. Let's do, how about, let's try this one. Y equals 4x. Is that a direct variation? Well, the y-intercept is 0. So yes, and the slope is this k. K equals 4. It has a constant of variation, which is the same thing as a slope. So we can actually graph this. Y-intercept is 0. And we're going to just graph the slope for, in the form of a fraction, would be up 4, 1, 2, 3, 4, and over 1. Up 4, 1, 2, 3, 4, and over 1. We could do the opposite, down 4, 1, 2, 3, 4, over 1. Down 4, 1, 2, 3, 4, over 1. And if we graph this, we get a direct variation. And it's just a straight line that always goes through origin. The y-intercept is always going to be 0. See that there? Okay, let's do one more. How about, let's go with y equals 1/3 x. Well, here there is no y-intercept, so that means our y-intercept is 0, which is what we need for a direct variation. We need our y-intercept to be 0. There's no number outs here on the outside, so that means our y-intercept is 0. And then our slope, or our k, is equal to 1/3, the number in front of the x. So we're just going to graph it, okay? So y-intercept is 0, and then the slope is, or the constant k, up 1 over 3, 1, 2, 3. Up 1 over 3, 1, 1, 2, wait, up 1 over 3, 1, 2, 3. Up 1 over 3, 1, 2, 3, and there we go. Then from this point, I can go the opposite, down 1 over 3 this way, 1, 2, 3. Down 1 over 3, 1, 2, 3. Down 1, 1, 2, 3. There we go, and we can graph that one. And if you see here, these are 3 different direct variation equations, but if you notice, they all go through the origin. They all have a y-intercept of equaling 0, okay? So I think on some of the problems, you're just going to have to look at a problem and see if it is a direct variation. So if you had something like this, y equals 2/3 x minus 1, would that be a direct variation? No, it would not, because it has a y-intercept there of -1. And direct variations always have a y-intercept of 0. So just looking at it, you would know that it is not a direct variation. Direct variations have to have a y-intercept of 0. Okay, just another little reading math thing. The constant of variation, which is our k, is also called the constant of proportionality. That's a little fun fact for you guys. Okay, so we're going to move on to our problems. The first one is here. This states we're going to determine whether the data shows a direct variation. Now, you can do this 2 ways. The first way is to graph it, okay, which is what we're going to do. We're going to graph and see if it, shows a linear straight line that goes to the origin, right? The second way is that we're going to look at the relationships. Okay, so we're going to these have to be proportional. So we're going to look at this kind of more. The ratios have to be proportional. Okay. So it's a proportional relationship with y over x. That is what k equals. K equals y over x, and so it has to be the same every single time. Okay, but first we're going to graph it. So here we go. This right here, the age, that is going to be our x, and this is going to be our y. Each one of these represents an ordered pair. So here we have 322, we have 624, 925, and 1220. That's a 2. 27. We're just going to go ahead and graph these ordered pairs here. This is the age in months, the x, and this is the length, which is the y's. We're going to graph these 4 points. So these are in twos, so 3 would be here, and then up to 22 would be right here. 624, here's 6 for x, and 24 would be there. The next one is 925. Here's 8 between 8 and 10. Is 925 would be right in there between 24 and 26. And then lastly, 1227. 1227. Okay. So, yeah, we would just go ahead and graph this. And I'm just going to go ahead and graph the first two. And if I graph these, what does it look like? If I connect those dots, I end up with something like this. Now, are all those points on this line? No. And does this line go through the origin at 0? No. So by graphing it, we know that this is not a direct variation. Okay, so not a direct variation. Okay? But we also want to be able to look at the ratios and the k and figure out what the relationship is. So some of you might have been like, hey, where did she come up with this k equals y over x? And if we have a direct variation, I'll show you how I got this right here. Okay, it's actually from the direct variation formula. Y equals kx, right? That's a direct variation formula. Now, if I solve this for k, that means I get k by itself. This is k times multiplied by x. So if I want to get k by itself, I need to do the inverse operation of multiplication, which would be division. I'm going to divide both sides by x. And actually what I come up with is y over x equals k, which is the same thing as k equals y over x. And that is how I arrived at this particular equation. It's just a different form of the same y equals kx form. Okay, so that's what we're going to do. We're going to be looking at these relationships. We're going to be looking at the k, y over x. So this is my y, and these are my x's. So I'm going to go 22 over 3. And that, if for a direct variation, all of these, this is my y, this is my x, all of these relationships need to be the same number. The k needs to be constant. That's why it's called the constant of variation. So 22 over 3 needs to be the same thing as 24 over 6, which needs to be the same thing as 25 over 9, which needs to be the same thing as 27 over 12. Now let's look to see if that's true. I'm just going to look at this fraction right here and see if I can reduce that fraction. Is there a number that goes into 3 and 22? I'm going to say no, there's not. Okay, so that one is reduced. But let's go ahead and look at this one. Is there a number that goes into 24 and 6? Yes, they're both even. That means that 2 goes into them. Well, how many times does 2 go into it? Well, 2 goes into 24 12 times, and 2 goes into 6 3 times, okay? So now we still have this 22 over 3